Today what we're going to be doing is looking at scientific notation. So first off, what is scientific notation? Scientific notation is a way to represent very large and very small numbers. The basic premise of it is you're going to have a number that is between 1 and 10. And so it'll look something like 2.73. In order to make this number really large, it's always going to look like times 10 and to a certain power, to the fifth power. And what this is showing us that I have this number, and when I times it by 10 to the fifth power, it is going to move this decimal to the right 5 places. So what I personally do is I just write 2.73 and a handful of zeros. And then what I'm going to do is I'm going to move this decimal now 5 spots to the right. Once, twice, 3, 4, 5 times. So that means my new number is 273,000. And then we're done. The other way to do this is look at numbers that are very small. So for instance, if I had 5.31 times 10 to the negative fourth power, anytime you have a negative exponent in scientific notation, what you're going to do is move the number to the left. So what I do, and how I solve these, is I put a handful of zeros on the left-hand side, and then I write the number as is. And now what I'm going to do is I'm going to move this decimal 4 spots to the right. Once, twice, 3 times, 4 times. So therefore, this number is equal to 0.000531. So that's how we write numbers from scientific notation that are very large and that are very small. So let's go ahead and do this. It says, I want us to write all these numbers into scientific notation. So it says the nucleus of a cell has a diameter of 0.000001 meters. And I want to convert this to scientific notation. First off, I want you to realize that this number is really small. It's smaller than 1. Therefore, we are going to have a negative exponent. I'm going to move this decimal over 1, 2, 3, 4, 5, 6 times, which means it will look like 1.0. Then I'm always going to have 10 times 10, and now it's just the exponent. Remember, it's my final answer over here in standard form is a small number, smaller than 1. Therefore, it's going to be a negative exponent. And I move the decimal over 6 spots to the right, so therefore it is going to be negative 6. Looking at this one, it says the average cell phone has an average of 918,440 germs on it. So this is a very large number. So to do this, I have my imaginary decimal right here. And I need to rewrite this number so it's between 1 and 10. So this would be 9.1844. Now I need to move this decimal over. So if the decimal's right here, to get it back to the original state, I would have to move it over once, twice, 3, 4, 5 times. So that would be times 10 to the fifth power. These numbers right here are equivalent. They're equal to each other. One is written in standard form, while the other is written in scientific notation. All right, so now I'm going to have them looking like this, which is kind of a combination between the two, and I need to figure this out. So we're going to use our rules of exponents to help us solve this. So if I just focused on 49,000 and I turn 49,000 into scientific notation, this would look like 4.9 times 10, and then if I notice, I would move it over once, twice, 3, 4 times to the fourth power. Now I'm going to rewrite everything else that I had here. This is times 10 to the negative second power. And I want you guys to remember on a lesson before us, when I have the same base and I am multiplying together, I keep the base the same and then I add the exponents. 4 plus negative 2 is positive 2. And I still have the 4.9 times. Okay. So looking at this one, we're going to do the same thing. I'm going to first start by just looking at this 0.00603, and I'm going to turn it into scientific notation. It's a smaller number, so I know I'm going to have a negative exponent. So the first thing I want to do is write this number between 1 and 10. So it's going to be 6.03. And then I'm going to multiply it by 10 to the negative something power. In order to figure out what that power is, it's going to move it over once, twice, 3 times, so it's going to be the negative third power. Last but not least, I'm going to rewrite everything else that they had here, 10 to the negative 8th. And as we did before, what we're going to look at is these bases that are both 10, and since I am multiplying them, I'm going to add my exponents. So it's going to be 6.03 times 10, and then negative 3 plus negative 8 is negative 11. And there we have it in scientific notation. So let's go ahead and do this one more as well. I have the decimal right here. It's invisible. I'm going to write this in scientific notation by moving it 2 spots to the left. This would be 3.22 times 10 to the second power. I know it's the second power because in order to make this to 322, I would have to move the decimal 2 spots to the right. And then I'm going to rewrite what I had before, which is times 10 to the 5th power. I have the same bases, so I'm going to keep my bases the same, and I'm going to add the exponents to put a 7 right here. I hope this video was able to help. If you have any questions, please feel free to email me or your teacher.